Yes, ma'am.
Let us get into adding this Terraform stage in the Jenkins. Before we get to all the setup, any questions you have from any topic in Terraform? Have you started your hands-on? Anything we have to discuss before we get started? Let me open our use this open folder. Okay. Strong address book one. Sorry. So this is the branch. Let's have a branch here. So let us visit our previous pipeline. If you remember, we were building our image, pushing to Docker Hub, and then deploying it, right? This is the pipeline we have, correct? But then we are creating this deploy server or dev server manually, isn't it? We are going to the console and creating those instances. But now I would like to automate at least deploy server. You could do both of them, but here I'm focusing on deploy server will be created by Terraform. So I am including a stage here between that build stage and deploy stage. See here, between the build stage and the deploy stage. This is the stage for Terraform. Here I'm just calling the Terraform code and then Terraform init, Terraform apply, getting that public IP of the EC2 instance through the output value and assigning it to EC2 public IP. This is nothing but trimming all the spaces, everything, and assigning to EC2 public IP. This will be used as a deploy server. That's all simple. Earlier, we used to have the deploy server IP, right? But now that particular instance is used as a deploy server. That's the whole point. That's the point you have to understand. Understood the point, everyone? How it is executed, I'll tell you. But what we are doing is we are creating deploy server with Terraform. So deploy server is, Terraform is creating the deploy server, correct? So what are we doing? We have kept all the code in this Terraform folder. Directory Terraform means going to that folder, Terraform init, Terraform apply. And then through output, we are grabbing the public IP, assigning that to this variable. This is being used in the next stage for deployment. That's all. Is this script clear? Directory Terraform means going to the folder. And by the way, we are running it on Jenkins master itself. If you want, you could put this stage on a slave also. But anyhow, I'm running it on master itself. Is this clear for all? Any questions in this Terraform stage? If no questions, that's a Terraform stage. And then the Other stage is the deploy stage where it's all everything is old stages. I'm not doing anything new. Just that instance which is created by Terraform, and here waiting for sleep 90 seconds means waiting for 1.5 minutes so that the instance would be up before searching into it, and then install Docker, start Docker, and the Docker commands. That's all. This is all what we have done already. Jenkins file is ready. And what else we have to check in? Yes, build a server. We have to use some build server. That's all we have to configure. And by the way, let's come here. Let's check the code one. See, I'm having only one web server. Why I'll tell you. Only one module web server, and I'm creating only EC2 instance, not the subnet modules. Subnet. Why I'll tell you. Just see here, only web server module is there. Output is EC2. So that is the output you should refer in Jenkins file. Here, I think name is different. Let me put it as EC2. Oh, sorry. This is the main output. Sorry. Main output is also EC2, then it should be EC2, or else here let me put it as EC2 IP. Okay. Variables.tf. Oh, sorry. This is not the main. This is not the main output. This is the main output. Perfect. This a main output should have. You should refer the one you see in the main output. Main output is what you see here. Right? Outputs terraform.tf var c2 micro south b and all variables.tf. Okay. In the main.tf, are we adding the right? Okay, 8080 is the one you can use. 8080 is added in the ingress. And also, okay, yeah, subnet is commented, and I'm not trying to running this shell script because I'll be installing Docker with this stage, right? I'm installing Docker this way. So I'm not using user data. So this is the final code, and that 8080 should be the forwarding one, correct? So now the thing is, why are we not using subnet module? Because here your Jenkins should connect to this deploy server and deploy something. Jenkins server is created in a default VPC. So if you have to SSH into the other machine, it should be also in the same VPC. So that's why I haven't created that in a separate VPC, but rather kept it in the default VPC. Understood, everyone? Any questions, let me know. Let's create a deploy server first. Sorry, build server first. You may automate build server also with Terraform. But let me just go with the build server as the manually created one. Amazon Linux 2. Instance type AWS. I mean, key pair is AWS. That's all. This is the build server. And also, let's get our Jenkins ready to run the pipeline. This is going to be the build server. Right. So build server IP I have given, and the rest of the things should be created by Terraform. So that's all we have. Let me commit this. Commit -am Terraform. Git push horizon Terraform CI CD. Okay, let us now go to Jenkins server. It should be started by now. Yeah, Jenkins, let me clean up this. Let me start Docker. Also, will clean up this. Clean up all images, everything there. So, system room, all. If any images running containers are there, it should be cleaned up. Sorry, Docker system room. Docker images. Docker PS. Okay, just cleaning up everything before we run the job. And one more thing is, so from Jenkins, I mean, the pipeline is executing Terraform in it, everything on this machine, right? So Terraform should be installed here. Let's get the Terraform. We installed Terraform earlier from our laptop. We have done from there, right? Like we have installed Terraform on my machine. You could also do this as we are running it from pipeline. Let us install Linux, Amazon Linux. So let us run these commands to manage the repositories. And then uh, Linux repository. What's happening? Okay, already those are there. It's okay. And then install Terraform. Right, as we are doing it from here now, it should be present. And also let us check here the Terraform stage. Terraform init, Terraform apply. Yes, so let us try running this and see what happens. Let's see. Let us push the code. So let us try executing this and see. If it is stuck up, we'll get started, but let's start Jenkins. System CTN, start Jenkins. Okay. Let's get the public IP. Jenkins is started. So let us run this pipeline now. This is the previous pipeline we have executed in the Docker or Kubernetes, I think, right? That's our deployed on Kubernetes. Anyway, now I'm deploying on standalone EC2 only, but via Terraform. Even this EKS can be created with Terraform. We'll talk about that later. Now let me just configure it with Terraform CI/CD. All output. And let's see, it should create the instance. It's building the image. It should push to the Docker Hub. And then comes the Terraform stage where it should create the deploy server. Okay, this is the one. Sorry, not this one. Java Maven private repos. So here it should push with the tag 38. Let's wait. Here it cannot push the jar to this. Maybe let's finish it. You can see here Terraform init started. Terraform init started. You can see here. So let's wait. It may take a minute. Yeah, see Terraform apply has been successfully initialized. Now it's applying. Let's wait. Here what it will do is it will also check for AWS configure. Isn't it? AWS configure should be there so that it would need those credentials to apply. If it is there, it should be fine. So let me check it out. It just got stuck up here. It also might be stuck up due to the same. Let me just abort this pipeline. Then those I'll stop this and restart it. It is just stuck up there. Let me put AWS configure credential so that it can be reused. Now let us connect to this and I'll put the credentials. Let me go to AWS configure. Let me check if those are the right credentials. Believe those are the right ones. Ah, those are the right ones only. So let me run the pipeline. Check if the public IP is changed. 173 is the public IP. Is public IP changed? By the way, Jenkins should be started. Start Jenkins.
మొత్తం కారిపోతుంది.
So let me start Jenkins. Let me about this. And let us trigger a new build. Somehow it's been stuck up here. Meanwhile, let it complete. What it should do is it should create deploy server. On that, the containers should be deployed. Pipeline, everything should be fine. Let's leave it for some time. Meanwhile, I would like to show you one more thing. Can I go ahead? Any questions in this part? Is the flow clear for all of you, or any questions in this part before I pick up another topic? All right, then let me show you one more thing here. Meanwhile, this takes time. So till now we have created our own module, right? We can also use modules, existing modules like modules from Terraform. Terraform is also providing you modules which we can use. So let me just use those modules and create a EKS cluster, Elastic Kubernetes Service. Like EKS we are creating manually, right? We can also do that. 1 second. And the folder, let me create a new folder as EKS. So we'll use this one. So first for EKS, we need to create some VPC, some EKS and all, right? Some cluster and the VPC compatible for cluster. We can customize or automate all of that. If you go to Terraform registry where we have providers, you could also see the modules. Here you can see providers and modules. So see, you can search for, see, this is the VPC module we are going to use, and then some EKS module, right? Or modules are already there. You don't need to write from scratch. Terraform module to create AWS VPC resources. What it does, README, everything is there, right? What are the inputs you want to pass? What outputs it can provide? Any dependency modules, everything, a very good documentation. Similarly on EKS, yes, you have all the documentation from EKS module, like like how you can create a cluster and all. So first I'm going to create a VPC which is compatible for cluster for EKS. So let's go here. We would like to create VPC which is compatible for our EKS. So when we are creating EKS, we should make sure, okay, let me create a file called vpc.tf wherein we'll call the module, right? See here, I'm creating, means, see, this is my own module wherein I'm calling this, sorry, this is the name I have given to the, yesterday, if you remember, when we are calling our module, this is user defined name and then we call the module. Same thing I'm doing, VPC AWS and some name to the module, passing the VPC CIDR block, and whenever we create a EKS cluster, we will create the subnets both in private and public, means private subnets and public subnets. Private subnets to hold the workloads. Worker nodes can be running in private subnets. Public subnets to run the load balancers, which you will be exposing to the external world. So we would be using both, a combination of public subnets and private subnets. So this is how I have added them. Enable NAT gateway, like for private subnets to allow the internet traffic, we have the NAT gateways. Okay. And then the tags here, public subnet, private subnets. Okay. And now private subnets, public subnets also, like if you take any region, AP South 1, in that every region will have availability zones, right? So every availability zone will be creating both public and private subnets. So we are fetching the availability zones using data sources and then creating subnets, private subnets. We need to pass those CIDR blocks as well. So we can have another file as terraform.tfvars where we define those CIDR blocks, terraform.tfvars. Here we can define those subnets. You have the widgets where you can click, which can help you generate this CIDR blocks. See, VPC CIDR blocks and then subnet CIDR blocks will be the subset of it. So 3 private subnets, 3 public subnets, because we have 3 availability zones. Every availability zone will have a public subnet and a private subnet. Okay. So I'm going through again. Provider, region, define 3 variables, VPC CIDR block, public subnet CIDR blocks, private subnet CIDR blocks. Availability zones we are fetching through the data source. So it will give you the availability zones. In each availability zone, 3 public subnets and 3 private subnets will be created, enabling the NAT gateway to allow traffic to the private subnets, and some tags to identify the cluster. This is the name of the cluster I'm going to give. So this tag will identify to which cluster these subnets will be used. Right? Let us do Terraform in it because we are using some modules from AWS. We are using this VPC. See here. Source is, earlier source is the path I have given locally, but now source is this Terraform init. Meanwhile, okay, it got executed. It took some time, but it went through and it has applied it. Let's see what happened. Apply. It will create, but it failed. Let's see the error. Where it failed, huh? It says that the security group already exists. We are creating again security group with the same name. That's the problem. Let me just clean it up. Let's go to the VPC console and clear the security group. Okay, and then we'll reapply. Security groups. There should be something like own security group. This one, let me clean it up. Delete the security group or give another name. Okay, now it should work. Still it's showing. Okay, perfect. Now let us apply, let us rerun this pipeline again. Build with parameters. Let us wait. Meanwhile, let's come to, yeah. See, it says that it is initialized. Let's run Terraform plan here. Terraform plan. And if you do apply, VPC will be great. Anyway, I'm not doing it because it will take some time and also it will spin up many resources. See here, subnets, VPCs, everything. So I'm not doing that anyhow. Okay, see 20 resources. So that's a VPC ready. Now let's create a cluster. I'm creating another config file, eks.tf. Here, if you see the official documentation readme tells you what this module does, eks. See, it is clearly telling you call the module version, cluster name, cluster version, and then the cluster VPC ID tags, everything, right? So that's what we are going to do. Okay, here you can see. See, these also you can mention. If you go over the document, you will also see this. EKS managed node groups. You remember, right? We create a managed node groups, minimum size 1, maximum 3, desired size. So that's what we are doing, right? And also here we are referring that's a VPC which is created in another module. Now that we are calling another module, do init. So the module should be installed. See, both the modules and then plan. Right? So you can see total 50 resources being ready. If you apply a CKS cluster will be created, all of it. It will take definitely some time, some 30 minutes or so. But that's the whole point. The point is we may need not write modules from the scratch. We can also use modules from the Terraform registry. Is this much clear? Understood? Meanwhile, let us also have a look at this pipeline, what's happening with it. Okay, it has created the Terraform. Do you see that successfully? right? It says resources are created and the public IP it's printing. Let's see. Yes, this is the one. Dev my web server. This public IP is the one it's printing. If you see 68, and that is where the things will be deployed. Meanwhile, let's check the build server. Image might have been pushed on the build and push on build server, right? If you remember and recollect, image will be built here. I'm doing on a browser connect. Image will be built and pushed to the registry. Here it might have pushed tag number 40. Tag number 40 might have pushed. Yes, pushed 4 minutes back. Okay, that is all happening on this build server. Yeah, code is present here where it will build the image. So image should be listed here 38, 39, 40. And but no containers are running. Container should be running on deploy server, which is nothing but instance created by Terraform. But that doesn't yet happen. Okay, I did not confirm to continue. So let me just go here. This is the server. Now let us confirm the next stage by providing input. It failed now. Let's see why it failed. Branch name. Somewhere I have used branch name. It seems no such property. Let's go for our pipeline. Where did I use the branch name? Okay, I think I just opened here. Let me open that back. Open the folder. Address book, TI, TCACD branch. This one. Branch name will work only for multi branches, right? So let me comment it. Stage agent, any should be fine. Commit Terraform code. Push. And let's rerun. This time it should work quickly because already infrastructure is created, but only deployment failed. So it should go faster now. So it's doing initialize. Let it finish this. May take a while. Meanwhile, any questions you have from any topic or in this flow, we can go over. It has progressed, but just now I think it has applied as it took that as halted. Let me trigger another build and terminate the old one. Yeah, it has progressed this time. Yeah, because it's already there, it should be fine. And it should go to the next stage. Let me confirm it. It should SSH into that machine. It will wait for 1 minute 30 seconds because the instance should be ready. But in our case, already instance is ready in the last run. But let it continue. We should see a successful deployment on the deploy server. You can see it has SSH into that particular machine and install Docker. Docker should be started and Docker login should be successful and it should run the container. So Docker login has done, successfully logged in, and it is deploying that particular image which is built in this run 42. So this is the deploy server. Finally, yes, we can see the container deployed in here. Yes, that particular image is pulled and you could see it running on 8080. We don't need to do anything. Even 8080 is added, open through the security rules, if you can recollect, through Terraform. So 8080 is already there here. So you just get the public IP, hit that on 8080. The endpoint is address book. This is your application. Are we good? Understood? Everyone? That is a complete Terraform pipeline, including all the stages. Like these are the stages: package, provision, and deploy with Terraform. Right? You could also, like now it's deployed here, but we provisioned EC2 instance. You may put Terraform code here. This directory, you may put the code of EKS or EC2, whatever it is. This doesn't change. Go to the directory, do Terraform apply. That's all. EKS cluster will be spinned up, then run kubectl apply command here. That's the only difference. Can you try doing it? We have done kubectl apply through CI/CD. We have done Terraform through CI/CD, and we have completed the pipeline with Terraform integration also. Just your Terraform code changes. You can try out with this EKS and deploy onto that EKS. Can you try this as an assignment?
Yes, ma'am.
Right. So this is the complete flow. So that completes the Terraform. We shall start with Ansible on Monday. Please do the hands-on. Terraform would be the challenge. I already mentioned you have to manage your Terraform config files, understand the flow, integrate it in the pipeline. So put more effort, try to execute or replicate these scenarios. Any questions, post it in the group or come up with the questions in the class. We are having some time left, but there are no questions, so no questionnaire. So you guys should be doing hands-on and coming up with more questions. Anything from your end? Anything you want to know?
Ma'am, one thing I want to know regarding the continuous integration. If someone suppose changes the code and the pipeline is triggered, then it always creating a new infrastructure through this Terraform. If we integrate the Terraform, or is there any
You remember idempotency, and also just now we have seen if already infrastructure is there, it will tell you no changes to be done, but it will not
okay?
recreate, right? Idempotency. So I'm using here, already it's created in the first run, second run, it just said no differences, no changes, and it just went on, but it will not
Oh,
recreate. We have idempotency, right? No changes. Infrastructure matches the configuration.
got it,
Only
ma'am.
if it is not there, it will, otherwise it will not recreate.
Sure.
So also you can destroy with the Terraform so that it would get terminated better. Any more questions from anyone? To safely get rid of it, I would just do from here. Replay. So here you can modify. I did Terraform. Apply. I just want to do Terraform destroy. Later on code will fail, but just I want to clean it up by itself. The Jenkins page may not be updated. There might be a lag updating. Here we should see terminating. You go to the VPC. I think VPC is already terminated. See, I don't see other VPCs. Only the default one is available. So it's getting terminating the VPCs first. Subnets are gone. Internet gateway also gone. Right? So it's working at the back end. It should update on the page as well. Let's wait. See, it's gone actually. Shutting down. Right? Of course, after that it will fail. I don't need all of that, just to clean up. So that's all from my end. Anything else? All right then. Thanks everyone. See you on Monday. Have a good day and happy weekend. See you.
Thank you, ma'am.
Thank you. Bye everyone.